All right, today we're going to be talking about the division properties for exponents. Our goal is to be able for you to use division properties of exponents to simplify and evaluate expressions. So copy down your target. This will complete our exponent rules. So we learned negative exponents, zero exponents, multiplication properties, and now we're going to learn the division properties. Pause the video, get your target and your warm up, and then you can press play. So for your first warm-up, you should get x to the 6. You're multiplying those. For the second one, you have a negative exponent, so we need 1 over 2 cubed, which gives you 1 over 8, or 1/8. On the third one, 3 squared is going to be 9, and then x to the negative 1 pushes that to the denominator. And the last one, we're going to be taking this negative 4 and giving it to each base. Remember that you multiply it by the exponent that's already there. So we'd have v to the 8th, w to the negative 12th. We can't leave a negative exponent in our answer, so we get v to the 8th over w to the 12th. All right, if you have any questions on these guys, you need to study those and practice them more before your quiz. So let's use repeated multiplication to solve the following problem. Let's think about what this actually means. 2 to the 7th means what? If you were going to expand that out, what would that actually mean? Well, it would mean 2 times 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7. Good. And then the denominator would just be 2 times 2 times 2 times 2. You see, I don't know 2 to the 7th right off in my head, and I could figure it out decently quick, or I could use a calculator, but let's expand it out. When you look at this expansion, think about what we did with factorials and stuff. When you see something that occurs, a factor that occurs in the numerator and the denominator, what would you do? I'd start canceling, right? So these 2's will cancel each other. These 2's, and these 2's. Which means I'm left with 2 to the 3rd, which then would be a much easier to evaluate. It would be 2 times 2, which is 4, times 2 again, which would be 8. But I want you to look for a relationship here, guys, between these exponents and your exponential answer. What's the rule? What happens when you divide like bases? If you know the multiplication rule, the division one should be easy, right? They're like opposites. When we multiplied, we added the exponents. When we divide, you're going to subtract the exponents. Make sure you write down these words and the example, okay? You need to have this on your paper too. Oops, sorry. I want to see this on your paper as well. If you need to pause the video to get that all written, that's fine. So moving on to the examples then. When we divide, I want you to start by showing me the step of work. We will eventually do this in our head. When we're dividing the same base, you just keep the base the same. That does not change, but you subtract the exponents. So you'd have 8 minus 3, which would give me a to the 5th. That's as far as you can take it. For the second one, again, dividing the same base, you're going to keep that base, but you're going to take the exponent and do negative 3 minus the exponent down here, which is a negative 5. Minus a negative, guys. Be careful with that. That's a number one spot where I do see mistakes, so watch that carefully. Minus a negative is the same as plus a positive, so we get x to the 2nd, and that's as far as you can take it. Down at the bottom, now you have more than one term in the problem. That's okay. Only combine the terms, or only do the exponent rule when you have the same base. So you're going to do the subtraction rule for the b. We'd have 5 minus 3. And that's being multiplied right now by c. So we will still multiply this by c, but it's going to be 9 minus 2. So you're going to keep your multiplication rules as well. We will do some problems where it combines all of them. So now we would subtract these exponents. We'd get b squared c to the 7th. It's one term. Remember, you can't leave negative exponents, zero exponents, and we want to get rid of as many of the bases as we can. See, we know this one right here is not fully simplified because we have a b and a b occurring. But now in our answer, we only had to write b once, and that's what we want to do. Try number 4 if you want to pause it first, you can. First thing I would do is I would take this exponent and give it to each one of the bases in the bottom. So a to the 4th, b cubed, c to the negative 5th, and I would take this 3 and give it to each the a, b, and c. So a cubed, b cubed, and c cubed. Whoops. Now go ahead and do your subtraction rule with each one. A to the 4 minus 3, b to the 3 minus 3. And yes, I will let you skip this step on your homework, but right now, guys, in the notes, I want to see it. So if you didn't write this, go back, erase it, and fit it in. And then c to the negative 5 minus 3. So that's going to give me a to the 1, b, 3 minus 3 is 0. Guys, what's anything to the 0 power? It's just 1, so that's gone. And then c to the negative 8th. Can't ever leave a negative exponent, so we'll have to move that down. A over c to the 8th. All right, so that was our quotient of powers property. We also have a power of a quotient, okay? The quotient of powers, let's go back to that real quick. Oops, sorry. The quotient of powers means that you have a quotient or a fraction, and it has powers, okay? Where if you go to the other one, now it's going to be the power of a quotient. We're going to raise a fraction to a power. That's all that means, okay? So again, use repeated multiplication to solve this problem. If I have 2/3 being cubed, that's the same as 2/3 times 2/3 times 2/3, right? Which means it's the same as 2 times 2 times 2 over 3 times 3 times 3. Now put that in exponential form. Well, how could you write this with exponents? 2 cubed over 3 cubed. I don't know why I keep doing that. So what did you do here when you started with an exponent outside of a fraction? All you have to do is give that exponent to each base on the inside of those parentheses. So copy down your power of a quotient property. Pause. This one does have a lot of words, so make sure you get it all written down and think about that. All right, so now let's combine this rule with our last one and practice this a little bit. If I have 2/5 raised to the negative 3rd power, you give each base that exponent. So we're going to have 2 to the negative 3rd, and we're going to have 5 to the negative 3rd. Now we can't leave a negative exponent in our answer, so think about it. Where would this 2 to the negative 3rd go? Well, it would be 1 over 2 cubed. But before I put that 1 in, think about this 5. This 5 to the negative 3rd, since it's starting in the denominator, where would it go to become a positive exponent? The power of 5 to the negative 3rd would go up, but the exponent would become positive. Then we can simplify that. Guys, what's 5 cubed? I would expect that you would know 5 cubed. 5 times 5 is 25, times 5 again, 125. And 2 cubed, yeah, you're definitely going to know that one, so always simplify that. All right, good. Try the next one then. How many bases do I have inside these parentheses here? The 2 is going to go to what? It's got to go to the 3, it's got to go to the x, and the y. Don't skip anything. So we're going to have 3 squared, x squared, and then what do we do with these exponents? We would have y cubed being squared. What rule is that? That's a power of a power. So we're going to have 3 squared, x squared, over y to the, what do? Add or multiply? Hopefully you're saying multiply, so we get y to the 6th. 3 squared is 9, x squared we'll have to leave, and y to the 6th we'll have to leave. No negative exponents, no 0 exponents, only one of each base, fully simplified. Last one in this example set, guys, maybe pause this one, try this. It has a lot going on. Take that negative 2 to each one of these. If you can do the steps in your head now, go ahead. Me personally, I would simplify what's in the parentheses first. So when I look at the parentheses, I would have 4 over 3. That doesn't change. I'm going to do the a's. 2 minus a negative 3. I'd have a to the 2 minus a negative 3. 2 minus negative 3 is a plus 3, right? So I'd have a to the 5th. That goes in the numerator. Then the b's, I would have 3 minus 4. Well, that would give me b to the negative 1 if I wanted to write that up here. But I don't want to leave a negative, so let's just put b to the 1 down at the bottom. Now we're going to raise that to a negative 2. Give that negative 2 to each base. So I'd have 4 to the negative 2, a to the negative 10th, over 3 to the negative 2, b to the negative 2. What's going to happen to that entire fraction, guys? Well, since we have this negative 2 exponent, we're going to distribute that to, or we already distributed that to each one. They're all going to have to move. So we will have a 4 squared down here now, and the 3 squared up here in the top in the numerator. a to the 10th goes to the denominator, and b squared goes to the numerator. Last step, guys, evaluate these ones. We can do 3 squared, so it's 9b squared over 16a to the 10th. Any questions for me? All right, last example. Well, yes, you can't ask me a question because this is a video, but write it down if you have one so you remember it for tomorrow. Number 8 and 9, scientific notation. Same thing applies, guys, for the multiplication. So when we were multiplying everything, we multiplied the numbers that were easier. We did this one and this one together. You can rewrite this problem the same way. So I can do 4.6 over 2 3/10 times 10 to the negative 4th over 10 to the negative 2. Take this first one, and that first scientific notation are your numerators. Take the second one, and the second number are your denominators. Then you can just divide each one. 4.6 divided by 2.3 gives you 2. And guys, if you don't like decimals, you can move it over. As long as you match the numerator and the denominator, your answer is good. So you have 46 divided by 23 gives me 2. Times, and then dividing, so we subtract, we would have negative 4 minus a negative 2. We'd have 10 to the negative 2. Scientific notation, you are allowed to leave a negative exponent on that 10. Is this in scientific notation, though? You always have to check. Yes, it is. Try the second one. Pause the video, try the second one, and then we'll go through it. So same thing for the second. We're going to set it up. We're going to have the numerators be from the first scientific notation number. And we're going to have the denominators be from the second scientific notation number. When you do your division, again, if you don't like decimals, move it over. It's easier for me to think of 38 and 76. 38 and 76, you can try to reduce instead of dividing, but I recognize those numbers. 2 of these makes up one of those. So if I divide it by 38, I would get 1 over 2. 1/2 times 10 to the negative 2. But I don't leave it as 1/2. I would have 0.5 times 10 to the negative 2. Is that in scientific notation? Is that a number between 1 and 10? No, it is not. We would move this over, making it larger, which means we'd have to change this to make it smaller. We would have 5 times 10 to the negative 3rd. All right, guys, make sure you check out your exit ticket or quick check on Blended Schools.